So this is a mini lesson on cycling of matter. Specifically, we're going to focus on the nitrogen and phosphorus cycle. What we have here is what we find in a lot of developments. This here is a stormwater retention basin or pond. And if you can see here, you'll see, if I zoom in a little bit, right there is the output pipe from this development over here. And this will capture all of the stormwater from the streets over there and then channel it here. And the purpose of it, quite honestly, is just to reduce flooding in our nearby surface water in creeks and rivers. So it's a good thing because it's capturing the stormwater and holding on to it for a while and then slowly releasing it. The only problem is that we have situations that arise that allow for the nitrogen and phosphorus cycle to go awry. What you can see here, if you guys can see, there's like a layer of algae that's growing on the surface. So what this is indicating is that this definitely has excess nutrients in this basin. Excess nutrients in the form of nitrates and phosphates. Nitrates and phosphates come from fertilizers used on lawns. So you can see how beautiful these lawns are over here. There may have been people that maybe incorrectly used their fertilizer, and they used too much of it, and it rained and it ran off and it went in here. When you put fertilizer or any nitrate phosphate in a body of water, it's going to cause algae to grow because it's a plant as well. So that grows. And when you have that excess algae, what happens is it will die and it will fall to the bottom of the body of water. And the bottom of the body of water is called the benthic area. The benthic is a fancy word for bottom. And so this dead algae just sits down there. And as it sits down there, it doesn't just stay in that state of matter as dead algae. It actually gets converted into other things by organisms called aerobic bacteria. Aerobic, going back to biology, means oxygen using. And so the bacteria that are going to be decomposing this algae here that we see eventually will be using oxygen in the water. So much of it to the point where it will turn the water conditions anoxic or hypoxic. And what that means is that it's very low or lacks oxygen in the water. Oxygen in the water is referenced as dissolved oxygen. So basically this body of water we could hypothesize will become slightly hypoxic or anoxic, meaning that there's not a lot of oxygen in the water eventually. And why? Well, it traces back to the aerobic bacteria that would be decomposing this dead algae, and they would be utilizing that dissolved oxygen in the process. And then what that leads to is a lack of oxygen in the water, and then all other life forms that require oxygen in the water would slowly begin to die out and cause what we call a dead zone. And so because we know that that happens, we put these things in called like little bubblers, and what they do is, you can probably predict, is that they add oxygen to the water. So it's basically just a band-aid, you know what I mean? Like if we would just correctly apply fertilizer in the first place, or just maybe use organic fertilizers and not commercial fertilizers, then maybe we wouldn't have all of these problems. This right here also is an example of a positive feedback loop. When you have a change in one direction, that leads to further change in that same direction. So step one would be fertilizer on lawns. Step two, it rains and it runs off into the nearby water body, which we see here. Step three, it causes an algal bloom. Step four, the algae dies. Step five, aerobic bacteria start to decompose it. Step six, dissolved oxygen becomes less and less in the water. Step seven, all other aerobic life forms like crayfish, bluegill, bass, zooplankton, macroinvertebrate larvae, everything else that requires oxygen out of the water begins to die out. And then I don't know what number we're on now, but everything dies. You see what I'm saying? So it just causes more and more problems. Another thing that it causes is the spread of disease. If you think of like these conditions, it's like perfect for vectors, which are carriers of disease, and vector is spelled V-E-C-T-O-R. A lot of times they're flies and mosquitoes are vectors of disease. they will breed in these conditions and then spread disease. So you see how I'm saying it's a positive feedback loop. It's one change in one direction causing further change in that same direction. Like a snowball effect. It's just like getting bigger and bigger and bigger and causes so many other problems. So that's that. Okay, so again, what did we just go over? The impact of excess nitrates, phosphates in water causing this. And this is actually called, this is a key buzzword here, this is called eutrophication. 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 Now, this right here that we have right in front of us is called cultural eutrophication, meaning the impact of human on eutrophication. So eutrophication is a natural process where it's the aging of a lake. I don't know if you guys knew this, but eventually all ponds and lakes will fill in over time, geologically speaking, and fill in with sediment, and things die and get buried, and like eventually the hole is not a hole anymore. It'll make a wetland and then eventually a forest. That's a natural process called eutrophication. We speed that up through cultural eutrophication, which is what we see here, even though this is a man-made body of water, and we cause the aging of the lake to happen faster. And that's because of how we use our land with fertilizers, and even other things.